Hi everyone, so I'm going to discuss a question from KMKT 23/24. The question states that the isopropyl alcohol composed of carbon, hydrogen and oxygen, and combustion of this alcohol produces carbon dioxide and water. So the question asks us to determine the empirical formula of isopropyl alcohol. And then the first step is we have to write down the chemical equation and then write down all the information provided by the question. The question doesn't provide us any chemical formula of the isopropyl alcohol, so we let it to be CXHYOZ first. And then in the end of the question, we will use this table to find the chemical formula of the isopropyl alcohol. So in order to find the empirical formula, we should use this table, and then we know that the first thing we want to find is the mass of these three elements, which is carbon, hydrogen and oxygen. So first we find the mass of carbon. So we have this chemical equation, which is 0.255 gram of the isopropyl alcohol undergo combustion to produce 0.561 gram of carbon dioxide and also 0.306 gram of water. We know that one carbon dioxide molecule consists of one carbon atom and two oxygen atoms. So in order to find the mass of one carbon atom, we will use mass of one carbon atom divided by the mass of whole carbon dioxide molecule, and then we multiply 0.561 gram. Then we will get 0.153 gram. Then to find the mass of hydrogen atom, same as just now, we know that one water molecule consists of two hydrogen atoms and one oxygen atom. So we will use the mass of two hydrogen atoms divided by the mass of the water molecule and times with 0.306, and we get 0.034 gram. To find the mass of oxygen, we can't use the mass given from the product because the oxygen will be used during the combustion. So to find the mass of oxygen, we need to use the mass of the reactant, which is 0.255 gram. So we use 0.255 gram minus 0.153, which is the mass of carbon, and then minus with 0.034. So we get the mass of oxygen, which is 0.068 gram. So we copy all the mass we get for each element into the table, and we are done for the first step, finding the mass of each element. So the second step is to find the mole of each element. So to find the mole of each element, we will use the formula N equal to mass divided by molar mass. So by using the formula, we will get the mole of the carbon is 0.0128 mole. And then hydrogen we will get 0.034 mole, and for oxygen we will get 0.0043 mole. So we are done for our second step. The third step is to find the simplest mole ratio. So we will use the mole we get to divide by the smallest mole, which we get from step 2. So the smallest value of mole is 0.0043. So for carbon, we will use 0.0128 divided by 0.0043, and we get 2.97. So we will round off and get 3. And for hydrogen, we will use 0.034 divided by the mole of oxygen, so we get 7.91, and round off we will get 8. And for oxygen, the simplest mole ratio is 1. Then we combine all of the information together, we will get the empirical formula of isopropyl alcohol equal to C3H8O. So this will be our final answer, and we are done for part 1. So for part B, the question will provide us each average atomic mass for silicon 28, 29 and also 30. And the atomic mass of silicon is 28.0855, and natural abundance of silicon 29 is 4.7%. So the question asks us to find the natural abundance of silicon 28 and silicon 30. So for this type of question, we will apply the formula. It's called KMPK. The relative abundance of the isotope of the element will represent by letter Q, while the isotopic mass of the element will represent by the letter M. To use this formula, we should collect all the information about the relative abundance and also isotopic mass for each element first. So the first thing we can find is the natural abundance of silicon-28 and silicon-30. So the question has given us the natural abundance of silicon-29. So in order to find the natural abundance of silicon-28 and silicon-30, we can use 100% minus with 4.7%, so we will get 95.33%. So we will let the percentage abundance of silicon-28 to be X. So the percentage abundance of silicon-30 will be 95.33 minus X. So we will know that the unknown for the question is X. So it will mean that the other value is provided by the question. So we substitute the atomic mass, which is 28.0855. Then the AMU for silicon-28, which is 27.9769, multiplied with the natural abundance, which is X, and then plus with the AMU of silicon-29, which is 28.9765, multiplied by the isotonic mass, which is 4.67, plus with the AMU for silicon-30, 29.9738, and the mass of the element, which is 95.33 minus X. And then divided by the total relative abundance, which is X, plus natural abundance of silicon-29, 4.67, plus with natural abundance of silicon-30, 95.33 minus X. So we do all the calculation. We will get X equal to 92.23%. So X represents the natural abundance of silicon-28. So to find natural abundance of silicon-30, we will substitute X by 92.23. So we will get 3.10%. So we have answered the question, which is to find the natural abundance of silicon-28 and silicon-30. So we have done for part B. We move on to part C. So the question is about the reaction between benzene and also bromine. And part 1 of part C, the question asks us to determine the limiting reactant. So the limiting reactant means that the mole of reactant given is less than the mole of reactant we need. So first step, we should find the mole given. So for benzene, the mass given is 30 grams, and for the bromine, the mass given is 65 grams. So again, to find the mole of the reactant, we will use mass divided by molar mass. So the mass of the benzene is 30 grams, divided by the molar mass, 6 times 12 plus 6 times 1, we will get 0.46 mole. So the mole of bromine, we use 65 grams divided by 2 times 79.9, we get 0.4068 mole. So this will be the mole given. Next, we need to find the mole needed. So from the balance equation, we know that 1 mole of benzene reacts with 1 mole of bromine. So the mole of the benzene needed, we need to compare to the mole of bromine, which is same mole. So the mole of the benzene will be same as bromine, which is 0.4068 mole. And when we compare the mole of bromine to the mole of benzene, it will also be the same. So the mole of bromine needed will be 0.3846 mole. So we compare with the mole of benzene, we found that the mole given is less than the mole needed. So benzene will be the limiting reactant. And then for part 2, question asks us to determine the mass of excess remain after the reaction completed. From part 1, we know that the benzene is the limiting reactant, so the bromine will be the excess reactant. To find the mass of bromine, we should find the mole of bromine first. So same as part 1, from the balance equation we know that 1 mole of benzene react with 1 mole of bromine. And then we'll always use the mole of limiting reactant. So 0.3846 mole of benzene will react with 0.3846 mole of bromine. And then to find the mass of bromine used, we will multiply by the mole of bromine with its molar mass. So it's 0.3846 times 2 times 79.9, we will get 61.46 grams. And to answer the question, mass of excess remain reactant, we will use the initial mass of bromine minus with the mass of bromine used. So we will get 3.54 grams. For part C, the question asks us to determine the percentage yield if the bromobenzene produced is 42.3 grams. So whenever the question asks us to find the percentage yield, we will apply the formula, which is actual yield divided by theoretical yield and then times with 100%. So the actual yield is probably the experiment result. It is provided by the question, which is 42.3 grams. So now we will need to find the theoretical yield. And then the theoretical yield we can predict by using the balanced chemical equation. So we write from the balanced equation, 1 mole of benzene will produce 1 mole of bromobenzene. So 0.3846 mole of benzene will produce 0.3846 mole of bromobenzene. So now we have the mole, and to find the mass of bromobenzene, we use the mole times with the molar mass, and we will get 60.34 grams, which is our theoretical yield, and then substitute the value to the formula, and the final answer will be 7.10%. And that's end of the question.